Hey, Vlad here, devinsideu.com. Welcome to another video. In the previous video, we have implemented our initial version of streams and played around with them for a bit. In this video, we're going to get a bit more professional and also write some tests. Let's get right to it. As always, we're in the Ubuntu virtual machine, which is fully maximized, and we're running Sublime Text, which is the editor of my choosing, which is also fully maximized. And we're using a wonderful plugin called Terminus, which runs at the bottom over here, which allows us to emulate an entire terminal, which we use to run SBT, which we use to rerun the tests every time we save the file. Now, in the previous video, we have switched to Scala 2.13, even though it's in RC3. And usually when you upgrade your Scala version, there will be a bunch of deprecation warnings, but we don't see them because we don't have them enabled in our build file. So let's go to our build file and enable that flag real quick. So we're going to go over here and we're going to say -deprecation like this, comma. Now we need to reload our project. And also you see only the warnings of the that are coming from the files that are being compiled. But if we compile now, then everything is already compiled. So we need to clean every time, right? We need to clean and we need to do test compile so that it compiles the production sources and the test sources, and it should generate a bunch of warnings. Now I already know where they're from because I'm prepared. So I'm going to go to test suite, and the first warning is going to come from Scala test. So the property checks, it moved to a different package, and it's now called Scala check property checks because Scala test is going to have their own generators soon in Scala test version 3.1. Right now we're using the Scala test version 3.08, right? So we're still at the 3.0, not at the 3.1. So as I said, it also moved to another package. So now it's not in Scala test prop, it's in Scala test, Scala check like this. Okay, so for now I'm just gonna keep compiling things like this. But again, only the warnings will be shown of the things that are being recompiled. In fact, this package is called Scala Test Plus now for some reason, and this is exactly why I'm compiling it all the time. The next thing we're going to do is we're going to go to the standard library map join. Now this is from the video about maps where we implemented joins for maps, and by the end of this video I also showed you how it works for because we implemented it as a DSL for our maps from the Homegrown collections library, but by the end of this video I also showed you that it also works for the standard library map join. And we imported the Scala collection map, and we're using the plus method on these maps. And in Scala 2.13 they changed it a bit, so there's a Scala collection map which has this plus, and then there are two versions of it. There are mutable maps and there are immutable maps. And the problem is that the mutable maps they also add another operator called plus equals, and it does the same thing. Some people found it confusing, and so now this operator was removed from one of them. So basically we're going to switch to just immutable maps over here because we don't really care about them, and now this warning is going to disappear because the plus operator is actually present on immutable maps. So if we click compile now, the only thing that should produce a warning as of right now should be in foldable, which relates to traversable, because traversable is being deprecated and it says use iterable instead of traversable. So we're going to go to foldable, and we're going to find the first instance of traversable. Right, so we're going to do this and we're going to do that, and we're just going to replace it with iterable. And now we're going to go down where we have our view from foldable to iterable, and we will actually implement iterator instead of for each, because it's kind of ironic, but in order to implement iterator, one of the easiest ways is actually to use streams, and we have streams. So I thought that it would be a good idea to actually implement this, because we actually don't need to override for each anymore, as we need it for traversable. By the way, traversable is being deprecated because traversable was basically at the top of the hierarchy, and then under it was iterable, or maybe the other way around. No, it was like this, right? And then one of them was removed because it was basically confusing for people. There's no reason to have two of them. Now, if you're not familiar with iterators, it's a very imperative, very mutable API, and it works in such a way that it's just an interface, iterator like this. So an iterable has an iterator, right? And an iterator, it has so it's an iterator of element, obviously, element, okay. And what it has is it has a final override def has next, which is a boolean, which is supposed to give us false if there are no more elements, and another one is a final override def next, which is an element. like this, right? So it's just going to give us the next element. I forgot the question marks. I just wanted to compile. Okay, so the way we're going to do this is we're going to have a private var. So we're going to have a private this var, and we're going to use our streams for that. So it's a timeline, timeline with a capital T, timeline of element. All right, and we're going to do from dot fold right. It's the same as to list basically. Timeline element timeline.end, and over here we're just constructing our timeline now. And the has next is just going to go and say, okay, so if the timeline is not end, right, then there's another element. Okay, and next is basically just getting the whoops, what happened? Come on, just mark these. Why are you marking them like this? It's so weird. All right, so we're just going to get the result from the timeline.get, and get throws an exception. And so this is by design, right? So by design, the clients are supposed to call has next first before calling next. So if they do it wrong, then it will throw an exception, and this is by design, right? Because we're forced to return an element here anyway. Okay. And now the timeline is going to be timeline.tail, and by the end, we're going to just return the result. Okay, and now we can actually go and play with it a little bit. So if we go to console, okay, so what we can do is we can say val iterable, which is an iterable of end, and we're going to use a list. This is our list, right? So this is the list from the Homegrown collections library because we have this import, right? So we're going to do this, and it worked because exactly of this implicit. Okay. So what we can do now is, because it's an iterable, it has for each. So iterable for each, print line, and it works as expected. So for each, inside of for each, it knows that it has to ask has next if it has the next element, and then it will just call next. We can do this also manually, right? So we can run it again, for example, or we can do it manually. So we can get the iterator from the iterable dot iterator like this, and now we have the iterator in our hands, and we can do has next. And now we can do next, which is the element. Now has next, true, element 2, has next, true, element 3, has next, false, and now the element is going to throw the exception. Okay, cool. Now we're not going to use it in the rest of the video. I just wanted to show you how streams can be useful for implementing this. So in fact, we were using this implicit for something. I don't even remember for what. I'm going to comment it out because we don't use it anymore, but I wanted to commit it, so I want to just have it commented out. So it's commented out now, and everything else should compile, and the test should still run because, as I said, we don't actually use it. In fact, what I'm going to do now is I'm actually going to commit it because we're done with the deprecation warnings. So I'm going to go and just add everything and commit -am, and this is video 31, right? And I'm just going to call it streams, Scala to 13, yeah, like this, just like this. All right. I'm not going to push it. I'm going to push it only by the end of the video. All right. So let's get to writing our tests. All right. Now, obviously, we're not just going to write tests because that would be boring. But in fact, we actually will start with writing some tests because testing streams is actually kind of tricky because we need to, the most important thing that we need to test for is not that, if we have a stream of 1 to 3, that we're actually going to get, 1 to 3 back if we call head. The most important thing is to test for those initialization leaks. So we're going to start with writing some tests, but we'll also, as I said, we're not just going to write tests. We're also going to get add a few definitions as well, a few new methods. Okay, so let's put the timeline on the right, and let's go over here and let's create a new file, and I'm going to call it timeline suite.scala, and I'm going to put it into a source test Scala user, yeah, right here. There we go, timeline suite. And in fact, maybe we should switch to just running that suite, which we probably don't even have yet. Hold up, test only. It's going to be user timeline suite like this, and it's just going to say that it doesn't exist. Okay, cool. So let's go to set suite, for example, and just copy that like this. Okay, just put it in like this, like that. I don't think that we're going to have a companion object. Okay, so we're just going to have timeline suite, and we're going to have a test hello world, and we're just going to say that 1 should be 1. Let's see. Yeah, it's green, and 1 should be 2, should be red. All right, so the hello world test works. All right, so let's start writing the first actual test. So we're going to call it init1, and we're going to just create a timeline, which is a timeline, not sweet, timeline of int, and it's just going to be a timeline, not empty, right? And we're going to say that the recent event is IO pure of 0, and the previous events is IO pure of timeline.end, right? So this is a timeline with only one element, and the next thing that we're going to do is we're going to make sure that nothing is initialized. Now let me create a bit more space. So in order to do that, we're actually kind of ironically are going to use the environment model of evaluation to test this. Okay, so we're going to go over here inside of the class, and we're going to create an abstract class, and I'm going to call it environment like this. And in this environment, we're going to have a variable, and we're going to call it events occurred. Events occurred. It is an integer 0. Now we're going to have a helper, which is going to be called side effect, which is going to work for any kind of event. You pass it an event, and it returns you an event, right? So it's basically like the identity function, so it just returns the event, but it also side effects a change to this variable, right? So it's just going to do a plus equals 1, like this. All right, let's see if it compiles, and it should. All right, cool. So now what we can do is we can go to our first test. We can wrap it in a new environment like this. All right, let's compile so that Scala form kicks in. And now we can go over here and we can say events occurred should be 0. And we can go over here and we can say list, which is a list of events, and we just gonna drain the entire timeline, and after this the events occurred should be 1, and the list should be list of 0, like this. Now the test is red because I forgot to actually use the version that creates the side effect. So we can go over here and use it. So we're not just gonna have a 0 here, we're going to have a side effect of 0, right? But side effect is just basically like the identity function. It just returns the 0 back. So this is still a timeline of int and not of something weird, right? But it mutates this variable, and therefore we can use this basically count to write our test. All right, so the next thing that we're going to do is we're going to test the head, and for the head we're going to create the timeline in all possible different ways. We have a factory, we have this manual creation, and we have these operators as well. So what we're going to do is we're going to start by adding a helper for all of these tests. So we're going to have a tiny helper here. I'm going to call it test head. It gets an event. It gets a timeline, which is a timeline of some events. It produces a unit. And the first thing that it's going to do is going to make sure that the events occurred should be 0. Then it's just going to get the head. It's going to say events occurred should be 1. Then it's going to get the timeline tail, and then head from that. Going to duplicate that, bring it down. Let's create a bit more space. So after this, it should be 2, and let's do it one more time. So we're going to go over here and say .tail again, and now it should be 3, like this. Let's see if it compiles, and it should. All right, so now what we're going to do is we're going to go and create another test. So we're going to go over here, and we're going to say test. We're going to call it init2, and we're going to go over here. I'm going to say new environment. Almost every test that we will write will use this new environment. And now we're going to say test head, right? And test head just wants another timeline, right? So we give it a timeline. It runs a few checks on it. Okay, so we're going to give it the same timeline as we have over here, but it is going to be a bit longer. Okay, so we're just going to do this, but now over here, instead of timeline.head, what we're going to do is we're going to press enter over here and create yet another timeline over here. So in fact, I'm going to copy this whole thing and I'm going to paste this over here, and this is going to be the 1, and I'm going to paste it again. I'm sorry, 1, this was supposed to be 1, this is supposed to be 2, and this one is supposed to end, right? Timeline dot end. In fact, maybe even like this. All right. Okay, something is wrong. Where is this coming from? Okay, this one. Is there one missing here? Like this? No? All right, hold on. Let's remove this one. Okay, so this is from here. This one is from pure. This one is from non-empty. This one is, okay, what's up with this one? It's probably this one. And we need one more. One more from here. and then the curly brace, which is from there. That should be fine now. No? Should have 3 of them. 1, 2, 3. Yes. In fact, we should have 4. I believe. No? Yeah, that one is good. All right, so let's see what it complains about. Test clause may not appear inside another test clause. Oh, that's what happened. All right, okay, so let's collapse it, cut it out, and put it down here. All right, let's see. Yeah, now it's green. Cool. Awesome. Now, this is obviously a very painful way to create timelines, as we have just seen. So we're going to write the other tests a little bit differently. But before we do that, I'm going to show you something else. Now, if you remember my videos about model of computation, you might remember that the normal order of evaluation sometimes evaluates the thunks multiple times. And so if we go over here and do this, for example, right, even if you just do it once, then our test should fail, because now it evaluated, it's called unsafe run twice. In this case, we can just go to head and make it a lazy val. Where is it? Over here. So it's not a final def. It's going to be a final, can actually be just a val. It doesn't even need to be lazy. But yeah, but we can also make it a lazy val. Why did it just die, actually? Hold up. What's up? Val? Whoa, 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 whoa. What's... null pointer. Really? Oh yeah, it's probably because it's an abstract class. So if you have abstract classes or traits, don't have vals inside of them, right? Okay, so let's have a lazy val, and in fact, in this case, it actually fixes the issue, but we might not always get so lucky, because in this case, head doesn't have any parameters, so you can make a lazy val out of it. But if it had a parameter, you wouldn't be able to make a lazy val of it. It would need to stay a def. Also, you might not always want to have this. So what we're going to do here is we're going to try to find a central place where we can sort of cache these calls to unsafe run and go from there. So what we're going to do is we're going to go to IO. I'm going to go to IO over here. And when we call over here, so what I'm going to have here is I'm going to have a lazy val, and this one doesn't need to be a lazy val. It's only a lazy val because I'm going to call it memoize, because I just wanted to work in such a way that if I call memoize multiple times, it's just not going to do anything. It's just going to return the same instance, right? So this is now where the caching is coming from. The caching is going to come from over here. So it's just going to create a new IO over here, right? It's going to create an IO pure of A. Now, where does the A come from? Well, it's going to come from here. It's a lazy val A unsafe run, right? So we're running it only once, right? And we're creating an IO pure that will just always return this lazy val. Okay, so let's see if it compiles, and it should. So now what we can do is we can go to timeline, and we can go all the way down. Okay, maybe not all the way down, but to the point where we have the non-empty case. And what we're going to do is we're going to make the constructor private, and instead we're going to have an object over here, non-empty, with a factory, which is going to be called apply. And I don't actually know the reason why, but if it works in such a way, then even if you're calling this constructor from inside of timeline, then it's still going to always call the factory. Somehow it works. It works out for us, right? So it's going to look exactly the same. So we're going to put it over here, right? And it's going to produce a timeline of event. And what we're going to do here is we're just going to create a new non-empty. New non-empty like this. Let me scroll down a little bit, and it's going to say that recent event is going to be recent event dot memoized. It's a fancy word, but basically it means cached. Previous events is going to be previous events dot memoized, like this. Now I forgot to add a, oh, why did I call it element? I just kind of used to calling it element. Okay, so now it says event, and now all of these tests will pass like this. Like this. So now all of them are cached. Now, as you can see, our tests are green, but we need to be very, very careful here, because we are in a language which allows side effects. And so our functions that we're putting inside of IO, they are not referentially transparent. So every time we call them, they might actually want to produce a different behavior. But if we cache them, they will only, they will trap the very first behavior, and we'll always repeat this. Let me show you what I mean. So the first thing that I'm going to do is I'm going to press enter over here, and I'm going to go over here, and I'm going to comment this out like this. So if you go and we try to run our playground, which should be somewhere, okay, whatever, I'm going to type it again. So if we do a run main homegrown collections playground, which is the one that we have written in the previous video, which is over here, right? If you're going to go down, this is what we have. So it's asked me what's my name. It's Vlad. What's my full name? Vladislav, not Vladimir. Vladislav. Cool, right? Okay, now it runs it again because it refactored something, but I'm going to press enter a few times. Okay, cool. But now if we go and memorize it, let me go over here, memorize it like that. Okay, now it says, what's your name? I'm going to say Vlad, and now it just captured that, and it doesn't repeat that behavior. So we don't always want this, but sometimes we do. And so what we're going to do now is we're going to have a tiny hack, which goes by the name of a global flag. I just need you to fully understand that I would never do this for a production grade library. I'm only doing this in the name of science so that you guys understand exactly what's up. So what we're going to do is we're going to go to IO, and we're going to introduce a global flag over here. We're going to have a bunch of helpers. So I'm going to have def is memoization disabled, which is going to be a boolean, which is going to return is memoization enabled. Was it not before? So is memoization enabled is going to be a boolean, which simply returns a private var, which is going to be called the same way as, hold up, is memoization enabled was an underscore, so it's going to be a private this var, which is going to be called like this, and by default it's going to be disabled. Okay, so it's going to be false. So now we're going to have a few basically setters. So we're going to have enable memoization, which is a unit, and it's just going to set the variable to true, and we're going to have the same thing for disabling. Copy that, paste that, going to have disable, and we're going to set this to false. Now, obviously for a production grade library, this would not work, and in fact, I don't need this guy. Hold up. Let's go back to our test. So for a production grade library, this would not work, right? Because you can call this at any time, and then part of your stream might be constructed was a memoized IO, and another part might be constructed was not without a memoized IO. So you never want that. But for our use case, it's actually good enough. Okay, so now what we're going to do is we're going to go to memoize. So every time we call it, we're going to check the flag first. So if it's disabled, and then we're just going to return this IO the way it is, and otherwise we're going to do the same thing as we did before. Okay, like that. It doesn't compile because we need to import IO like that. Import IO. There we go. All right, cool. One test failed. This is the same test. In fact, in timeline, it's no, it's enabled now. Why did it fail? Oh yeah, because by default the memoization is disabled. And also I didn't want to run all the tests. I wanted to run only these ones. Okay, so now it's going to fail. I can scroll up a little bit. 2 was not equal to 1. Okay, so what we're going to do now is we're going to go and fix the environment a little bit. So we're going to go over here, and the first thing that we're going to do is we're going to make this a private var. So it's going to be a private this var, and what we're going to have is we're going to have a helper that will test. It's going to say events occurred should be expected, which is an integer, right? So, and what it's going to do is it's going to call a different overload of the same function with expected twice. So for some tests, so we're going to run the same test twice, one with memoization and one without the memoization. And sometimes the results will be the same. So we're going to have this one, and sometimes the results are not going to be the same. And so we're going to have a different version of it. The first one is going to be called when memoized, and the other one is going to be called when not memoized, like this. Okay, so what it's going to do is it is going to say expected, which is an integer, right? And it's going to calculate it somehow. And in the end, it's just going to say events occurred, which is a private var now, should be expected, right? So all it's going to do is it's going to say if io.is memoization enabled, then we expect the first one. Otherwise, we expect the second one, and that is all. Now, because this is a private var now, it's probably not going to compile. So line 20, it's basically just like that, and that's going to be a 1 like this. Same thing over here like that, and it's going to be a 0 like this. All right, not found value events occurred should be. Let's go down. Events occurred should be. It's there. What's the problem? The problem is that an R is missing. Occurred like this. All right, now the test is still red. Now it compiles, but we need to be very careful because we have this helper test head inside of this class, but we still want these guys to call the method. Okay, so we're gonna do this like that, and the S is gonna be over here, like that, and like that. Okay, let's see now. 0, 1, 2, 3. Okay, so now what we can do is we can go to our test head. So over here we can say that for the memoized version it should be 1, but when we don't memorize it, then it should be 2. And for this one it should be 4, and for this one it should be 6. Okay, cool. So now the last thing that we need to do is we actually need to run both of them. So we're going to go over here and we're going to make this an abstract class. Okay, so we're going to make it a sealed abstract class like this. And notice that Scala test is not going to pick it up only because it's abstract. So what we're going to do is we're going to go over here and we're going to say final class timeline suite with memoization extends timeline suite like this. IO enable memoization like this. And we're going to have another one which is going to be without, and it's going to enable like that. All right, let's see. Okay, so now we should have not just 2 tests, but actually 4 if we actually run them. So we need to go over here and we say timeline suite star, and then it's going to run both of them. So now we have 4 tests. We got two of the same ones, and now everything is green. But there is a tiny problem. So what we're going to do is we're going to go to the events occurred function over here, and we're going to put a print line to make sure that it's actually doing what we want it to do. Okay, so what we're going to do here is we're going to say print line when memoized, and over here we're going to say a print line when not memoized. All right, let's see. Okay, so what's happening is that we're always seeing this one, and the problem is that by default SBT runs the test in parallel. So Scala test by default it runs the test sequentially inside of one suite, but SBT runs multiple suites in parallel. So what we need to do is we need to disable that. It runs them in parallel, by the way, just for to run them faster. So we can go to our build SBT and we can just go somewhere. Let's do it at the bottom. Like somewhere over here, we can say in test, let's do parallel execution and just set it to false. And we need to reload, and hopefully it's going to be fast. It should be. Yes, let's run the tests. Okay, so now what we should see is when memoized and when not memoized. So this is exactly what we want. Let me go and remove that print line. Maybe I can just press Ctrl Z a few times. I'm just going to remove them. And like this, there we go. All right, so the tests are still green. There are no print lines, all good. All right, so now we can go and finally start implementing the other tests. Let me close other tabs. So let me go up over here. So we have the init1, we have the init2, and then we're gonna have init3, which is not gonna do this whole nonsense. It's gonna, create them much faster. Hold up, I don't want to do the same mistake like this. Okay, cool. So we're gonna do test init3, and it's gonna do new environment, and it's gonna say test head. And just going to create a timeline like this with a set effect of 0, comma, duplicate it twice, 0, 1, 2. All right, let's see. Yeah, cool. So the next one is going to be init4, which is going to copy that, paste that over here, init4. And in this case, we're going to use the add function. So we're going to say timeline.end.add, and now we're going to have set effect 2. We need to reverse them, right? Because remember, stacks 1, 0 like this, and now we don't need these. Like that. Okay, did I remove one too much? No, I think it's all good. Okay, we're going to do the same thing with prepend, right? Init5, prepend, and we're going to do the same thing with after. That's going to be init6. In fact, maybe we don't need to maybe we don't need to have these inits all the time, because we can have multiple environments in one test, right? So we can go over here and we can say after. Okay, so let's just remove these. Whoops, these like this. So we have multiple environments in this one, multiple environments in this one, multiple environments in this one. The only downside to this is that if it fails, then we're not going to see it immediately. This one is actually kind of large, so I want to leave it on its own. So we're going to have 2, 3. So this 3, it has 3 environments, so everything should be great. So what we can do now is we can go and add yet another one. We can do this one with that weird function, just call it like that. And we can also do this trick, which works only with was the infix notation like this. So instead of that, we're just gonna do, so it's gonna be set effect 0, prepended to set effect 1, prepended to set effect 2, prepended to timeline dot end, like this, right? So that thing didn't work in Scala 2.12. And let's also create a slightly bit different one. Let's create an infinite one. So let's do init, well, we have 4, I believe. Init 4, let's collapse this one. All right, so init 4, and it's going to create a new environment in which we're going to have a function called ascending. It's going to start from some seed, and it's going to generate a timeline of ints, and it's going to create a set effect of seed, and it's going to prepend it to itself with seed plus 1. So we can have a timeline of integers like this, right? It's just going to be ascending with a seed of 0, and now events occurred should be 0, right? Because we're just creating this timeline, but we're not evaluating it in any way. We're not draining it, and we're not doing anything like this. Next thing that we're going to do is we're going to have a function for, a test for add many. So we're going to call it just, it's still sort of init, but we're going to call it add many 1. Okay, so we're going to have a left timeline over here, timeline int, which is going to be a timeline of set effect 0, and let me do that, 0, 1, 2, 1, 2, and we're going to have right over here, right, clone that, go down. Okay, so this one is going to be 3, this one is going to be 4, this one is going to be 5. Now we're going to combine them in different ways. It's not a blah, it's val combined 1, just timeline of int equals right dot add many left. Now we're going to have a few versions. We're going to have combined 2, which is going to say prepend many, right? Because in this case, it's we can combine all of these into this one test. We don't need to create multiple different environments. So combined 3 is going to be this one, okay, and combined 4 is going to be over here. Combined 4, the one that actually looks decent, is going to be left, right, like this one. Okay, so now what we're going to say is that after all of this, the events occurred should be 0, and the expected list is going to be like this. It's going to be a list of 0, 1, 2, 3, 4, 5, and Scala Reform is going to fix that. So now we're going to go and say combined 1, forced should be expected. And we're going to do this, and we're going to go over here. We're going to say it's a 2, it's a 3, it's a 4, and I made some typo somewhere. Why didn't you tell me? Oh yeah, I forgot to put the whole thing into an environment. All right, so we're just going to go over here, new environment, like this. Love auto-completion, like this, like that, and fix everything for me, and it should be green now. Yes, it's green. Awesome. We're also going to copy the this test, this init4 test, and we're going to use it to write a test for add many 2. Right, so we're going to have add many 2, and we're just going to add a colon here, and we're going to wrap this whole thing into a timeline of its own, like that. Let's see. Yep, still green. Awesome. The next test that we're going to write is going to be for the take function. So we're going to have take, and it's going to have a. I know that we're writing many tests right now, and it's not always super fun to write them. But you know, it's going to get easier, and also we're going to add a few more cool methods in just a second. Okay, so we're going to have a timeline of side effect 0, and we're going to copy that and paste it over here. So this is going to be 2, this is going to be 2, and this is going to be a 1. So we're going to have a t, which is going to be a timeline of int. It's going to be timeline dot take -1. In fact, I'm going to do this like that. Okay, so after this, events occurred should be 0, and now we're going to have t0. It's going to take 0. Now we're going to go over here. We're going to do t1, take 1. Events occurred should be 0. In fact, I'm just going to paste it 2, 3, 4. All right, so in fact, let me do this. I think this is better in this case. Hold up, like that, like that, like that, like that, like that, and like that. And let's go down like that, and like that, and like that, like that, and like that, and like that. In fact, I'm just realizing now that we don't need all of these. We can just say that by the end it should still be 0 like this. Okay, so we can have 0, 1, 2, and 3, and 4 like this. Let's see if I made any typos, and it looks like I didn't. Okay, so now let's see if it actually works. So we can do should be list.empty, list.empty, and we're going to do t0.forced should be list.empty, and after all of this, events occurred should still be 0. Maybe let's do it like this. Okay, now let's do t1 forced should be list of 0, and now for the first time, events occurred should be actually 1. Let's scroll down like this. Okay, so let's do the same thing for t2. Okay, t2 forced should be list of 0 and 1, and events occurred should be. Now for the cached version, it's going to be 2, right? But for this one, it's going to be 3, because it's going to take the 2 from here and the 1 from here. Okay, 2, 3. Now let's do t3. t3 should be 0, 1, 2, which is all of them. So I'm going to get this, scroll down like this. So now it's going to be 3, because it's 3 elements, and over here it's going to be 6. Now, if we're going to do the same thing was the 4, 4. Now 4 takes 4 elements, okay, but we have only 3 elements. So the result is going to be the same, and for the cached version, the number is going to be the same over here, but this version is actually going to go up, right? Up by 3. Okay, so the last one is going to be to actually force the entire timeline. The one that we had originally should be list of 0, 1, 2, 2 like this, and events occurred should be 3 and 12, and my neighbors are building something again. Now we're going to keep reusing this timeline with 0, 1, 2. So what I'm going to do is I'm going to copy that. I'm going to go down, and I'm going to paste them into here, and I'm going to call this timeline 0, 1, 2. And in fact, I'm going to make it a def. Okay, like this. Okay, just in case. So now I can go 0, 1, 2, and I can go and use it over here. And maybe over here. This is 0, 1, 2. You know, these ones I actually want to test the construction. Okay, so this is fine. All right, so the next thing that we're going to do is over here. We're going to write a test for the reverse function. So I'm just going to call it reversed. Okay, and I'm going to create a new environment in which I'm going to have a timeline events, and it's going to be 0, 1, 2. Cool. Now I'm going to have it reversed, which is a timeline events is timeline dot reversed, and events occurred should be 0. I'm gonna have it as a list, and let's do it like that. And I'm just gonna say reversed dot forced, and now events occurred should be 3, and now the list should be list of 2 1 0 because it's reversed, right? Cool. Now let's look at our implementation of reversed actually for a second. So reversed is over here, and we have a custom loop to implement it. Let me actually create a bit more space over here like this. So we have a custom loop, but if we actually go to list and we find reversed over there, then over there we're actually using fold left. So why don't we introduce fold left? So let's go to fold left, which is over here. Let's just copy the whole thing. Let's find our fold right. Let's put it above it like that. Let me create more space like this. All right, so the element is called event, and we're matching on end, and we're calling this, oh, why is it called event? I wanted to call it recent event. Recent event like this, like that, like that, like that. Previous event is going to be this, previous event, and now over here we obviously need to call unsafe run, and over here as well. Okay, so over here I'm going to call unsafe run like this. Let's see what's up. All right, it overrides nothing like this. There we go. So what we can do now is we can go to list and find the implementation for reversed, which is just a fold left. So we can copy that, and we can go to our timeline, find reversed, throw the whole thing out like that, and just paste it in, and it's going to be end, and this is going to be timeline, and this is going to be this can actually this can actually stay add, and this is called event. Okay, timeline event and add. Oh, our tests are red. What's up? 3 was not equal to 0. 9 was not equal to 0. All right. So, by the way, one problem with our approach is that it always says that the arrow is at line 236. No, hold on. This is list 236. Now, this is the place where we have the helper, so it's actually not that useful. But in this case, if we go to take and we find the place where it says 9 was not equal to 0, which is probably either over here or over here or over here. Either over here or over here. Okay, so we have a problem in our implementation, and the problem in our implementation is the same as we did in fold right. So if we go to fold right, then the original fold right on lists only had an arrow for the result, but we were forced to add an arrow, the by name arrow to the fold right over here. So we're going to go to fold left, and we're going to do the same thing. Going to add an arrow to the event, and all of a sudden all the tests are green. Cool. Now, just to be clear, the reversed thing, not because of the implementation, but reversed in general, it only works for finite streams. So if we copy this, for example, and we're going to go to reversed to our test, let's just go and create another environment over here like this. Just paste that in. So now if we're going to do reversed, which is a timeline of ints, and if you're going to say ints, take 3, for example, dot reversed, then the events occurred should be 0, but if we do reverse dot forced, it should be a list of 2 1 0, and this obviously works, right? But as soon as we remove the take 3, it is not possible to reverse something that is infinite. Yeah, as you can see, it is already struggling. In fact, if I press F11, so as you can see, it says done compiling, but it's actually running something, right? So it's running. My CPU is going crazy, and I thought it would actually Stack Overflow, but it doesn't. It's probably just an endless loop. All right, so let's try to kill it, and I'm always observing my CPU if the killing actually worked or not. So I'm going to close the this one, and I'm going to wait a little bit. I'm going to cut this whole thing out from the video so that you don't have to wait. And we're back. I actually ended up killing Sublime and the Java process that comes from SBT. All right, so the next thing that we're going to do is, so I reverted that thing back, okay? So the next thing that we're going to do is we're going to copy the test for take, and we're going to do the same thing for a list because I sort of want to maintain the list as well. So I'm just going to go to lists and add the take function because we don't have it yet. So I'm going to put it somewhere over here. All right. Oh, I actually copied the test. Hold up. List suite. Let's go down. and just put it over here. And I'm gonna go to lists and put them over here on the right. All right, so let's go fix our test real quick. So we don't need the environment anymore, so we're gonna remove this, and we're gonna remove the curly brace. Now this whole events occurred thing, we don't need it, so I'm gonna do that, and that might actually be it already. We can actually inline a few things, so we don't need this whole thing, right? So we can just say should be here. This one should be here. This one should be there. And in fact, I can do this probably like this, like this, like that. Select all of these like that, like that. And although we have 2, 3, 4, and we need another one, timeline dot. Okay, like that. And have 4 cursors, paste. All right, like this. Okay, so it's not going to be timeline. It's going to be just a list, and this is a capital L. This is going to be a list of 0, 1, 2, and we don't need these. Should be fine now, but we obviously don't have take yet. All right. So we need to implement take, and we can just copy paste it. By the way, you can for lists you can implement take in a different way. Actually, in the preparation for my video, I implemented it with fold left, but the fold left version is not gonna work for the timeline. Okay, so I'm gonna paste that. Let's fix it a little bit. So it's not timeline. Everything that says timeline is gonna be called list. And okay, this is a small L. And this is a small L, probably missed some. All right, so let's see, let's not call it event, it's element, like that. It's not a recent event, that's element, and that's not previous events, that's other elements, and there's no unsafe run. And the function is called like this, and let's see if I have forgotten something. Okay, there's no n, there's empty. Probably the same thing over here, empty. Okay, it's not empty. Oh yeah, I forgot one of the L's over here, like this. This is not the error message that I wanted to see. It's super cryptic. All right, so yes, the tests are green, awesome. All right, before we write the next test, we actually, if we look at our timeline, then in our for each function, we're still having this manual loop, but in fact, in the timeline, I'm sorry, in list, in foldable, in fact, foldable. If you look at for each, it is implemented with fold left. So let's do the same thing. Copy from here, go over here. Throw the whole thing out, just paste it. In fact, in this case, we actually don't even need to do unsafe run. There we go. Now, when we were implementing lists, I actually omitted one function because I really didn't want to have it, and it's the apply function. So it is typical for ordered collections to ask them to retrieve an element by its index, by its position. But for lists, because lists are not index collections, they are they're linear collections. It is actually inefficient, right? So it's a linear complexity to retrieve a specific element. So I didn't want to add it, but in fact for timelines, it is actually important. And so we're going to add a test for lists and for the timelines. And so we're going to add the apply for both of them, which is going to look exactly the same. So we're going to have a list, which is a list of, let's do strings, and we're going to have a list of 0, 1, 2, and it's going to map to string. Okay, so now what we can do is we can say that a list of -1, it should be none. A list of 0, it should be sum of 0, and we're going to do this, and it's going to be 1, it's going to be 2, and the list of 3 in the third position should be none, like this. All right, so now we're just going to go to list and add this function. List is over here. Okay, so in fact we can go to the top and we can say that list is not just a foldable factory. Let me press enter over here, but it is also a function 1, right? So it's also a function that takes an int, takes an int, which is the index, and produces an option of element like this. And we're actually gonna do it over, let's do it over here. Okay, so we're gonna say final override def apply, which is going to take an index of int like this. It's going to produce an option of element, and it's going to be a loop, which is going to be tail recursive annotation dot tail rec, and by the end we're going to call the loop with this and with the 0. So the loop, it is going to take the list, which is the list of elements, and it's going to take the count, which is an integer. Okay, so it's going to produce the option of element, which spotted a typo over there, right? So all it's going to do, it's going to say if index is less than 0, then it's none. Otherwise, if count equals index, then list.head. Otherwise, just loop with list.tail and count plus 1. Let's see if I made any typos. It looks like I didn't, so it should be green, and we can actually copy paste the same tests and add it to the timeline. In fact, let's copy paste the implementation first to the timeline. Let's just copy that. Let's put it somewhere let's put it at the top like this over here. Let's also do this trick with the function. Let's do that, and let's put it down over here like this, but it's the first one, so it's going to be extends, and there's no element. It's up like this. There's no element, there's only event, and there's no list, there's only timeline. That's going to be timeline like that. I still got the element over there. Let's do event like this, and it looks like it compiles. Super awesome. So now we can just go and add the test for the timeline suite. It should be similar, it should look similar, but we shouldn't forget that we're testing the environment as well. So we have test take, we have reversed, and over here we're going to have apply. So that's not going to be, it's going to be timeline, that's going to be 0 1 2. Also going to map it to string. It's going to be called timeline like this. In fact, we're testing the map for free actually. Okay, so all we need to do is we need to add one of these lines, for example, over here like this, and duplicate it like that. Duplicate it over here like this, like that, like that. Duplicate it like that. There we go, and that should just be 1. Whoops, 1. That's going to be a 2, that's going to be a 3, and that's going to remain a 3 because there's only 3 elements. The fourth element is not there. It's not called list, it's called timeline. Let's see. All right. Did I forget to? Yeah, obviously we don't have the environment. Environment like this, and environment over here at the bottom. Yeah, that looks much better. It's green. Now there's some code duplication over here, so we can refactor this code into something like this. So we can say 0 to 2, which is a range for each was the index. Okay, so now we can, for example, copy that, paste it over here, remove the comments like that, and we can say that this is going to be a timeline of index. This is going to be a sum of index dot to string, and that's going to be index plus 1 like this, and it should test exactly the same thing. Let's comment this out. I'm sorry, I meant let's remove the comments. In fact, we could also implement size. Let's do that. So where do we have size? We have size in foldable size. Can we just copy paste it? I believe we can. Copy that. Let's put it somewhere close to for each maybe. Fold left, fold right for each. There we go. Let's put it over here. All right. So we have the size, and therefore we can go over here and we can say 0. Instead of 2, we're going to say until timeline dot size. All right. And because we have this events occurred, we're actually testing the fact that size doesn't actually touch the elements. It's kind of funny because size, it actually uses fold left, so it touches all the IOs, but it doesn't go inside of the IO, and it doesn't call unsafe run because it's not used here. And so the current element is not used, and in fold left, the current element is a binary parameter. So this is why we don't touch them, which is really awesome. The next thing that we're going to do is we're going to have a test for the toString function, which we don't have yet. to string. So what the string is going to do is going to do the same thing as it does in the Scala standard library. In fact, in the 2.13 version, it doesn't do that, but in the Scala 2.12 version, I actually kind of liked what it used to do. It would evaluate the first element, which was evaluated anyway. But in our case, it's not evaluated, but we will for toString. So we're going to have a new environment, and we're going to have timeline, which is a timeline of events, which is the 0, 1, 2, and we're going to have events occurred should be 0, right? So no, in fact, I just wanted to scroll down. I didn't want to create so much space like this. All right, so we're going to have a val over here, which is going to be tail, and it's going to be console.green plus dot 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 plus console.reset. So I want the streams to be printed out in such a way that if we have a timeline to string, then it should be string interpolation over here. It should say timeline. I usually call them, HCC timeline for homegrown collections and so on. But in the Scala standard library, it's called stream, and we call it timeline. So it's going to be 0, and now it's going to be tail like this. And events occurred should be 1, like this. Should be 1, and we're going to do the same thing again for the tail. Right, tail. Oops, tail, and that should still be 1, and that's 1. In fact, it probably should be 2, shouldn't it? Oh, let's see. All right, and what we're also going to do is we're going to print it out timeline and timeline dot tail. I believe I just have it wrong in my script. All right, so the 2 tests failed because because we're extending a function right over here, then the toString looks like the one from the function, and it's not what we wanted. Okay, so let's go and implement toString. Let's put it somewhere at the bottom. Zip, take, reverse. So let's have it over here. In fact, where's interleave? I didn't see it. It's over there. Cool. All right, so final override def toString, which is just a string, equals string interpolation. That's going to be a timeline, and then we're going to have toString content, which is going to be over here. It's going to be a private this def toString content. It's going to produce a string. It's just going to match on this. And if we're at the end, it's just going to be an empty string. Otherwise, if it's not empty, it was recent event and previous events, then we're just going to have a string interpolation in which we're going to evaluate the first element. Okay, so we're going to go over here. I'm going to say recent event. I'm going to say unsafe run on it. But we're not going to do the same thing for the others, right? So now we're going to do console.green. I wanted to have these dots, and my truck point is going crazy. Stop. There we go. All right, and then we're going to have console.reset, and let's see if I have any typos. In fact, green should be completely capital. Green like this. All right. All right, it's still failing. Let's see what I did wrong. 2 was not equal to 1. Oh, okay. Let's see. Yeah, I knew it that it was wrong in my script. Yeah, because why would it stay 1? It touches the next element, okay? And we have these print lines, so we can scroll up, and this is how the timelines are rendered, right? So this is the first one, and this is the tail with 3 green dots. All right, awesome. Let's remove the print lines like this. Let's scroll down over here. Cool. Now this video is getting kind of long, so I'm going to start copy pasting a few tests from now on, unless they're kind of special. So the first one is going to be the quality test, and let's see if I have any typos in my script. All right, so if I just paste it over here, so we have a timeline which is a 0, 1, 2, and timeline should not be the end, and the end should not be the timeline. Okay, so let's see. This one should be green because this one doesn't need anything special. All right, the next one is going to be the one that compares compares the this one, timeline 0, 1, and timeline 0. So A should not be B, and B should not be A. All right, so that's also a given. And the third one is actually not going to pass. So let me copy that. Let me paste it over here. So we have 0, 1, 2, 0, 1, 2, and now they should be the same. And let's see if it actually works without these. No, it doesn't. All right, so now we need to go and actually implement equality. And for equality, we actually need isEmpty and not empty. So let's actually go to list and find isEmpty. We don't have it. What is empty? Does it come from somewhere else? Foldable factory? No, isEmpty. Oh, we actually forgot to add it to list. All right, hold up. isEmpty. No, that's sad. Let's go to the tree. is empty. Yeah, this is what we need. In fact, we're going to do this for the list as well. So I'm going to go to list, and I'm just going to throw them in somewhere, like over here. It should actually compile, right? Because for lists, it's also called empty. And for timelines, where did I put it? Above fold left. So we're going to do the same thing, fold left, like this. It's just called end, like that. All right, so now we can go and implement equality, and I'm going to put it above toString or below toString. I'm going to put it above toString, like this over here. Okay, so we're going to have a final override def equals other any. It's going to take a boolean. It's going to actually look a little bit like zip, right? The only difference between zip and equality is going to be that zip is going to give up if the lengths are different, but equality has to make sure that the length is also the same, right? So it's going to be, if that's an event, then we're going to run a full-blown check, and otherwise it's just going to say false, like this, maybe even like that. All right, so the implementation is relatively simple. So we're going to say if this is empty and that is empty, then sure, and they're the same. Otherwise, if only one of them is empty, right? If this is empty or that is empty, right? And because we already have this one, then this one makes sure that only one of them is empty, right? Because this is technically an inclusive for. Okay, so in this case, then they cannot be the same, okay? And otherwise, we're going to do the actual check. It's actually kind of funny because we're actually going to use pattern matching over here to implement equality, because all we need to do is, all we need to have is just this structuring. Okay, so we're going to have and 2, and 2, and that. Okay, so when are they the same? Well, they're the same if we actually call unsafe run on the elements, and we're actually going to disable formatting over here. Format off, and we're going to recurse, obviously, tail unsafe run equals and2 tail dot unsafe run, and I believe this should already be everything that we need. Yep, the test is green. Awesome. Now in my videos about Scala check, I told you that property-based tests are really good for testing equality. So we, for our next trick, for our next equality test, we're actually going to need the generators, and we need to create them in a bit of a weird way, because we need to somehow put the side effect in there. So what we're going to do is we're going to go to the environment over here, and we're going to go over here, and we're going to say that it will contain an implicit val arbitrary, which is an arbitrary for IO of int. This should be a capital A over here, okay? And it's going to be an arbitrary of gen, which is a common pattern, and gen is going to be here. It's going to be a gen of IO of int. Right, so we want to generate a timeline of ints, but for this we need a gen of IO of int so that we can put a side effect in there. All right, so we're going to have an arbitrary dot arbitrary, which comes from Scala check, and we're just going to map that to n, right? We don't care that n is already evaluated. We can do IO pure side effect of n, like this. Let's see if it compiles. It doesn't know arbitrary like this. It happens to me all the time that I say arbitrary instead of arbitrary. The next thing that we're going to do is we're going to go to lists, which are somewhere over here, and somewhere in here we're going to have the arbitrary here, this whole thing. Just going to copy that, paste it to timeline, and we're going to go down over here. Yeah, maybe let's put it at the bottom. Yeah, let's put it at the bottom like this. Paste that in. Now we need to do we need to make a few changes. So this is going to be an arbitrary of IO of t. So in fact we can't use the context bound, right? So first we're going to rewrite this to we're going to remove the arbitrary from here, and we're going to put it over here. We're going to say implicit arbitrary, which is an arbitrary of, it used to be t, but now it's going to be IO of t, right? IO of t. So this is going to generate an arbitrary of timeline of t, and let's create more space because it looks weird. Okay, so an arbitrary of timeline of t, it's going to go to arbitrary gen t. So the gen is going to have the same trick. So we're going to remove that from over here, and we're going to have that like this. Paste that over here, and we're going to generate a timeline. We're going to use the container of method, container of, and we're going to use the Scala dot lazy list, which is the new stream, and IO of t. So now we're going to go to this arbitrary and just say dot arbitrary, which is one of those things that I find confusing about Scala check, right? So because this actually returns a generator and not an arbitrary. Okay, so we're going to map it, and we're going to map it to a bit differently actually in this case. So we're going to do this like that, and that's going to be a lazy list. And we're just going to say if lazy list is empty, then let's remove that. If it's empty, then we're just going to do timeline.end. Otherwise, timeline lazy list dot head unsafe run, or lazy list. Why am I saying or? Adopt the var args like this. That should be already enough. It's not, because we're missing an import. Okay, so we're going to do, remember in the video about monoids, we created the math library. In the math library, we have math library package object. Over there, we have the type aliases for the arbitrary. This is why I just imported that instead of importing Scala check. All right, let's go down again. Okay, and let's also have the one for the non-empty. Oh, it's all over there. So let's do this. Let's do that. Let's say gen non-empty, and we're going to use the non-empty container off. And over here, we're just going to say sys.error should not happen. All right. Okay, there's a problem somewhere that it did not format my code. Why did it not format my code? Let's see. Did I forget? Here, format off. Forgot to format on. Format on like this. Let's go down. Yeah, no, it's actually fixed. Okay, great. I believe that now we can actually write a test which will grab this arbitrary over here. So we're going to go over here where we have test equality 3, and as I already said, I'm going to start pasting stuff. All right, so that's going to be over here. It's going to be equality 4. All right, let's create a bit more space like this, and in fact like this. Okay, so we're calling for all from Scala check. We have our timeline, which needs an arbitrary. In fact, let's not use the arbitrary. Let's use the gen. Let's remove that arbitrary. I don't like it. Over here, like this. Okay, so let's go. Let's go over here. So say events occur should be 0. A is a timeline. B is a timeline mapped to identity. This just makes sure that structural equality is involved instead of the referential equality. After that, events occurred should still be 0 because map does not evaluate anything. A should be B, and whenever timeline is not empty, then events occurred should not be 0. And then we're going to reset the events occurred counter, because for all is going to generate a bunch of tests. So we obviously need to add this helper. Let's go and edit. So basically, we can go down and just copy these, paste them below, probably below. And it's going to be here, should not be, and over here should not be, like this. Okay, there's only one that is missing. It is this reset thing, like that. Let's put it somewhere over here. It's going to be a def, and it's going to return a unit, and it's just going to do events occurred equals 0. Like this. All right, what's up? Let's go up. Really, 312. Okay, hold up. It worked with an arbitrary. Why doesn't it like that? Let's introduce it again. Maybe for some reason. Yeah, probably the implicit resolution will grab the one that I need. IO of int, which is just an arbitrary of gen, and let's go to 312 and remove that. Let's see. Okay, could not find implicit value for evidence parameter math library arbitrary. Really? Event to event like this. Happy now. Happy now. Cool. Now we're almost done here. The next few tests that we're going to write are going to be for the zip function. And if you remember in the previous video, I actually planted a bug into the zip function. So the first one is going to be this one, zip. So we have a timeline events. They're both empty. We zip them together. It should be still empty. In fact, for zip, I prefer to do this. A zip B should be timeline empty. Okay, for the next one, we're going to have a slightly longer test. In fact, I'm going to type a part of it out. So I'm going to copy that like this, paste that over here. As you can see, it's only the first part of it. Okay, so we have an environment in which we have a timeline of a tuple int and string. So we have 0, 1, 2. We zip it with 0, 1, 2 mapped to string. So events occurred should be 0. So we take 1, which should be this, and after this, events occurred should be 2. And then we take 2, and after this, events occurred should be 4, I believe, but we're not gonna use it just yet. So let me just do this and that. All right, so at the very end over here, events occurred. Hold on, events occurred should be 6 and 12 over here, right? So this is 1, 2, 3, 4, 5, 6, and if we don't cache them down, it should be 12. Let's see what's going to happen. It's going to say 6 was not 12. So what happened is that in both cases it was actually 6, and this is happening because in the zip function we have lazy vowels. So if we go to zip, we have these lazy vowels, head and tail. So in fact, we just need to remove them. Okay, so we just need to do, take this, put it over here, take this, put it over here, and just remove these lazy vowels because we don't need them anymore. And now the test should be green. And in fact, why didn't I have it for here? So this should be probably 4 and 8. 4, 8. Let's see if I guessed right. I didn't. What does it say? 6 was not equal to 8. Oh yeah, it should be 6 because of the 3, right? I kind of thought that it was the double of the 6, but it's not the double of the 6. It's the how often it runs this 3 things, right? So here it runs it 4 times, here it runs it 2 times. Okay, so let's go down. It's green. Awesome. Let's improve this one a little bit because it looks kind of weird. So let's, instead of using this guy, let's rewrite it with the prepend syntax. So we're just going to say previous events, and we're just going to call unsafe run on them, and then we're going to zip with that previous events, and we're going to call unsafe run. And after that, we're going to say recent event dot unsafe run. Not after that, but this whole zipping is going to happen after that event dot unsafe run. Okay, so it's the same code, just that instead of this we used after, and after is not a write associative method. Okay, so now just looks a bit prettier. Okay, what's up? Okay, that's obviously a typo. It should be this one. There we go. Everything is green. All right. Let's go back to our tests. We're almost done with the tests. So the next 2 tests, they basically just make sure that zip stops if one of the timelines has a different length. So I'm pasting 2 tests in there actually. Let's see if they compile. They don't. Okay, 397. Result is called timeline. It's not result. Timeline. There we go, and they're green. Okay, so let's run through them real quick. So we have the zip 3. It creates a timeline with 0 and 1, creates another timeline with dev inside you, 3 strings, it zips them together, events occurred should be 0. Now it just has 0, 1 dev inside, so it stripped out the u because this one didn't have a 2, so it just has dev inside, and it tests the equality for timelines, and it tests the equality for lists. And this one is doing the same thing, but it just doesn't have the u, but instead it has the 2, but the result should be exactly the same. So it does this for the timeline, and it does this for the list. Now let's also copy paste the zip function from timeline to lists. Let's take the whole thing here, and what do we have it relatively at the bottom, right? Okay, so we have it under toString. So let's find toString. Let's put it, yeah, which is at the bottom. Cool. So let's put it over here. Let's create more space. All right. Okay, maybe that's too much space. Cool. So that's going to be a list over here. List and event. In fact, I can do event, right? Like this. Yes, awesome. I can just do element. Okay, so list element, that element, case empty, then okay, all the ends are going to be empty. Okay, so we don't have the after, we have add. We don't have the unsafe runs like this. That should actually be enough already. Okay. Cool. Now we don't have the test yet. In fact, this is so short that I believe we can actually go back to using this syntax over here. So we can do that, and we can do that, like this, like that. It actually fits into one line, especially if we rename this into just element. So this is going to be that. Whoops. That's going to be that element like this, like that, and that's just going to be other elements, and that's going to be that other elements like this. Okay, so this is the zip function. Let's go to list suite, which is over here. Let's go down and let me copy paste that test for them. It's going to be here. It's going to be there. There we go. All right, so let's see. We're testing the empty ones. We're zipping the ones with different lengths. Again, with different lengths, but swapped, and the ones with the same lengths. And let's see. It should be fine. All right, so the last thing that we're going to do is we're going to do the same thing for interleave. I believe that this is the last thing. So we have the test for the zip for timelines. So we're going to have interleave over here. I'm going to paste that in. So empty ones, interleave should be empty. That's kind of a boring test. Now we're going to take that one, going to paste that in over here. So we have 0, 1, 2 and 0, 1, 2 map to plus 10. So we have 0, 1, 2 and we have 10, 20, 10, 11, 12. Okay, so if we interleave them, then we take the 0, then the 10, then the 1, then the 11, then the 2, then the 12. Okay, let's see. Should be fine. The next one is going to be interleave 3, which is going to come from over here. So it takes the 0, 1, 2, 3, and then just the 10. And it makes sure that it takes the 0 from here, then the 10 from here, then the 1 from here, and then there's nothing from here. So it just keeps taking from this one, 1, 2, 1, 2, 3. And interleave 4 should do the other way around. So if the left one contains less elements, then it should still be fine. So it takes a 0 from here, then the 10 from here, then it sees that there's nothing there, so it just keeps taking from here, 11, 2, 3, 11, 2, 3 over here. Okay, let me save it again. Obviously, we're going to do interleave for lists as well. So let's find interleave over here, take it, put it to lists. Okay, there we go. So let's see. It's not going to be event. It's going to be element. It's not going to be timeline. It's going to be list. It's not going to be end, it's going to be empty. It's not going to be recent event, it's going to be element. It's not going to be previous event, it's going to be other elements. We're not going to have the unsafe run. And this one is called like this. Wow, first try, I believe it compiles. All right, and let's do the test, which is going to be similar to zip, like that. Here, right? So it's very, very similar. So we have two empty lists. We have lists with different lengths, so it just keeps taking from here. Same here, keeps taking from there, and with the same lengths. All right. So one of the last things, in fact, I actually believe that this is the last thing, is going to be flatten. So flatten and flat map, they look very much the same. In fact, hold up, flat map. All right, so I'm going to flat map. There's a reason why I do this. Okay, so flat map over here, and the function is called usually view, and it is implicit. All right, and it's called flatten. All right, now I'm doing this so that I can write a test with Scala check, right? So property-driven test, so that I can do test flat, and then this one I'm actually going to tap out. So if I'm going to have an environment with for all, not for each, okay, for all. So we have the inner, which is a timeline of int, arrow to the right like this. Then we have outer, which is a timeline of int, right? So it's just a timeline of inner 3 times, inner, inner, inner. Okay, so now outer dot flatten should be the same thing as outer dot flat map, and we can use identity here because of the arrow. because of the by name error over here, right? So identity doesn't match that. So we have to do event, and this shouldn't compile because of the same problem with flatten over here, right? Flatten has this arrow, and so the compiler cannot inject it into flatten, right? Because this is a nested timeline over here, right? So the compiler should be able to call flatten, right? So the compiler should be able to inject this implicit over there, but it can't. So for this, we need to add somewhere in the object timeline. In fact, maybe at the very top so that it's visible. So I'm going to say that this is required. This is required for flatten, and I'm going to say that it's called implicit def force a, right? So it just takes the a, returns the a, like this, right? So it's basically like identity, but it is implicit. And obviously I forgot the by name error, which was the most important thing. That's exactly why we need this thing. Okay, all right, cool, it works. And yeah, that's pretty much that should be enough for today. So let's just commit this whole thing. So I'm gonna add everything, commit -am. In fact, I like to do this when I do this. All right, so that's gonna be video 31. It's gonna be streams. I'm just gonna call it testing, like this, and let's push that, unlock my key, like this. All right, we don't need this anymore. Okay, so now it's pushed. Let's go over here, click on commits, and click on this one. In fact, maybe also let's also open the previous one. Come on, go back. So let's open this one and this one. Okay, so in this one, we just added the deprecation flag, and we fixed all the issues with the whole deprecation. This was the iterable example. Yeah, and this was just the thing for the map and the thing for Scala test. And over here, what we did was we disabled the parallel execution. Let's create more space over here. Yeah, so we disabled the parallel execution. We added memoization to I/O with a bunch of flags, which is a dirty hack. Okay, we went to list. We make sure that it's a function now. We added apply, edit is empty, non empty, edit take, edit zip, edit into leave. We went to the timeline, did the same thing. Function apply is empty, not empty, edit fold left, edit for each, edit flatten, edit reversed, edit equals. No, we fixed reversed. Reversed, we already had reversed. Just looks like as if we had edited. To string. What else? Fix the zip, fix the bug that I planted there. We have this fancy thing for flatten. We have a factory for non-empty that uses the memoization. Yeah, we have the arbitraries. We have the tests for lists for take, and oh, this one is a big one. Let's load it. Okay, so yeah, basically it's the whole file. We just added a bunch of tests. Man, how many lines of code did we just do? Oh my god, 592. That's crazy. All right, that's all I got for you today. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you. If you find my videos valuable, consider supporting me on Patreon. But most importantly, take care.